We did some few questions yesterday. We're continuing on with those questions. So, looking at what this question is saying, can you tell me the measurements for each of these lengths? So, what is the measurement for A?
7.5 centimeter.
One second. 7.5. You're saying 7. Okay, so you're taking the first length as 7.5. Do you see? Okay, it's not starting at 0. It's starting somewhere ahead of 0, yes?
Yes.
So, can we say 7.4 instead?
Yeah.
Okay, right? Can you tell me the measurement for B, the length B? It's starting at 0. So, here we can check the exact measurement.
4 centimeter.
How much?
4.
4 centimeters, yeah?
Yeah.
And then how much is this?
2 centimeter.
Look closely.
2.1 centimeter.
Okay, let's check. It's actually 1.9. Okay, so this is 1.9. Okay, so you've got 1.9 centimeters, 4 centimeters, and 7.4. So we put this here. And since we're always going to be using meters, can you convert all of these into meters? How much would this be in meters? 7.4 divided by 100 is how much? You'll move the decimal 2 places back, yes? So it would be 0.074 meters.
Yes, sir.
Right? Makes
Yeah.
sense?
Yeah.
So what will the value in meters be for 4 centimeters?
0.04.
Exactly. And when you're talking about 1.9 centimeters, how much will the value be?
0.019.
0.019 meters. Calculate the volume of the metal cuboid and give your answer in cubic meters. So what will we do? How do you find the volume? Do you know how? Volume is length into breadth into height. Okay. So you will multiply all three of these values. So 0.074 multiplied by 0.04 multiplied by 0.019. Can you give me the value? Am I audible?
Yes. Yes, sir. 1 minute on calculator. So I would get it as 0.00005624.
Sorry, again.
0.00005624.
5, 6. Now, can you write this in standard form? Do you know how to do that?
Yes.
Okay. So when we're talking about standard form, you only have one digit before the decimal, and then you have something which is called the power of 10, right? So you're moving towards the right, one decimal place, two decimal place, three, four, and five. So you're moving towards the right. Towards the right, when you move, the power is negative. So you have 5.6 into 10 to the power minus 5. Okay, meter cube. Make
Yes.
Okay. The student measures the mass of the metal cuboid on a scale. That measurement is shown. It's 146 grams. So how much is that in kilograms? What is the conversion from grams to kilograms? Divide by 1000. Yes. Yeah. So you have 146 grams, and you'll divide that by 1000. So what value do you get?
0.146.
0.146 kilograms. The densities of different metals are listed in the following table: kilograms per meter cube. So can you say its mass per volume? Yes. Okay.
Yes.
Okay. So use the information in the table to identify the type of metal which the cuboid is made. So what is the volume that you have?
3 meter
The volume was
meter
zero
cube.
point double zero double zero five six. So that's divided by 0.146. Yes.
Yes.
Okay. Now can you give me the value? What is the value? Am I audible?
Yes, sir, I can't find it. Sir, I can't find it.
You can't find it. Okay. All you have to do is put these values and divide it. Na? 0.146 divided by 0.000056. Put this in the calculator, find the value.
So we can use calculator?
Yes.
2607.14286.
Okay, so which value is this close to? Yes.
Aluminium.
So it is most likely made of aluminum.
Yeah.
Okay. So you've got 20 by 5 by 30. The pile contains 500 sheets of paper. Calculate the average thickness of one sheet of paper. So thickness is 5 centimeter. And how many sheets are there? 500. So what is the thickness of one sheet?
5 divided by 500, I guess.
Yes. So how much will it
100.
be?
100. 0.01.
How much?
0.01. I guess 100.
0.01 centimeters. Yes.
Yeah.
Okay. So can you find the volume? Find the volume and see if it says the same.
Is it 5?
Sorry. You will multiply all three of these.
Uh, 20 3,000.
Yes. So it does, right? So you can say 20 multiplied by 30 multiplied by 5 is equal to 3000. Hence shown. The stone measures the total mass of the upper of the paper in the pile. State the name of the device used to measure mass. What device is used to measure mass? It's called a balance. You have this thing, right? This apparatus, which is used to measure two different types of objects.
Yes.
Okay. So the mass of the paper in the pile is 2,400 grams. Calculate the density of the grams of the paper. So you have 2,400 and you have the volume, which is 3,000. Can you find the density?
Mm, 8,000 divided by 2,000. So should we divide it, I guess?
It will be mass over volume, right? So mass here and volume is here.
1.25.
Right. What does the next question say? What did you say was the value?
1.25.
No, it's supposed to be mass over volume, no? So check again.
Yes. 4.8.
Again?
0.8.
Yes, 0.8. A teacher investigates the reaction time of five students. A zero point 0.5 meter ruler is held above the hand of a student before being allowed to fall. The arrangement shown in figure 3.1. As soon as the ruler falls, the. Okay. So, what they're doing is they're leaving this ruler from this height, and this person grabs it, and his reaction time is measured here.
Yes.
Okay. Using the results shown in the figure, calculate the average distance the ruler drops. So, what is this distance? What is this distance? What is this distance? And what is this distance? First, let me know in sub the values.
So
And this one.
the lowest one. Yeah.
Can you tell me all of them?
Eight. One is 8, and then and then 9.
What is the first one? Just tell me A, B, C, D, and E. क्या क्या values are?
A is 9,
A is 9. Okay. B is
12,
12. C is
8,
8. D is
16.
and 22. Last one is 22, right? Now, how do we take out average? Do you know how to take out average?
No.
Yeah. So, what is the average?
Thirteen point 13.4.
How much is the total?
The total was 12, 67.
67, right? And how many values are there?
1, 2, 3, 4, 5.
5 values, right? So, how do we take out average?
67 divided by 5.
Yes. So, what is the value that you're getting?
3.4. 13.4.
13.4 centimeters. Good. List the students in order of their reaction times with the shortest reaction time first. So, who has the shortest reaction time? Sorry? Your voice is quite muffled. Are you saying C? Yes. So, after that, look at these values. So, if C is first, after that,
A.
A, right? And then you have B, and then
D.
D, and then E.
E.
In a similar investigation, a ruler drops a distance of 11 centimeters and has an average speed of 16 centimeters per second. What is the reaction time? So, what will you do? You'll take this distance.
And add it.
So, we have the triangle, right? This triangle, which says distance, time, second, speed, right? You have the speed and you have the distance. So, distance over speed gives you time. So distance is 11, speed is 16. So what is the time?
Distance over speed. 1.45.
Again, solve it again.
0.6875.
I can't hear you. There's something wrong with the mic. It's muffled, the volume.
So I'll begin.
I think 0.69. Okay.
Yes.
So figure 1.1 shows a large tank containing water. The tank leaks drops of water from the tank. The drops hit the ground at a regular rate. This fluid measures the time interval between two drops of water hitting the ground. This to use a stopwatch and repeat the procedure 3 times. Figure 1.2 shows the stopwatch reading. Okay. On the line below, each stopwatch states the time reading shown in seconds. So it's 1.24 seconds, 1.14 seconds, 1.16 seconds. Okay, makes sense.
Yeah.
On the line below, okay, calculate the average time interval between two drops hitting the ground. So you've got three intervals, so you'll take the average. What is the average?
One. 2.76.
How many values are there?
3.
Three values, right? And what is the total for all three values?
3.54.
So
3.54 over 3. So what is the value that you're getting?
1.18.
1.80.
1.18 seconds.
Yeah.
Another student measures the average time taken for a drop of water to fall from the tank to the ground. The time taken is 1.6 seconds. Calculate the average speed of this drop of water. So you have the distance, which is 12 meters, and you have the time. So distance over time gives you speed. What's the value?
13. Wait. When we add 1.6 and 12, we get 13.6.
Why would you add them? You have the distance, and you have the time, and you have the formula. You just want speed. Okay, so you have the time. This is your time. Yes,
Yeah.
12 meters is your distance. Yes,
Yeah.
What you're asked is speed. Yes. Distance divided by time is speed, right?
Yes.
So can you put these values here? Yes.
Yes. 7.5.
Yes. 7.5 meters per second. Okay. Are you fine with continuing further, or do you want to end it here?
I wanna end it.
Okay. We can solve more questions in the next class.
Okay, sir.
Okay. After